All right, so we want to start this video looking at, if we go back to the first slide, what's called the greenhouse effect. You guys looked at this a little bit yesterday. You looked at a lab where you looked at how these greenhouse gases absorb infrared radiation. So we want to look at this in more detail. We want to look at what's called the greenhouse effect. Now we need to remember that the greenhouse effect is a good thing. It is, I'm going to move this over a little bit so we can see everything. It is what keeps the Earth warm. And so if we didn't have the greenhouse gases in our atmosphere, the infrared radiation would come onto the Earth, would not be held in the atmosphere, and we'd be about 60 degrees Fahrenheit colder than we are right now. But what happens is we've got the sun, and you've got three possibilities. The electromagnetic radiation can come down from the sun and bounce back off into outer space. It can bounce off a cloud, or it can go into the Earth, warm up the Earth, and then come back out. The infrared radiation come back out into the atmosphere and bounce around and be held onto by greenhouse gases. So let's start with that. So I'm going to draw a sun here. Well, actually, let's do this. I'm going to draw, this is the Earth right here. Color this in blue a little bit. Okay. And we're going to call this the Earth. And then around the Earth, we have the troposphere. And then beyond that, we're just going to go to the stratosphere. That's as far as we need to go with climate change right now. Okay, so if I put a sun here, then the electromagnetic radiation from the sun is going to come through here, and it's going to come into the atmosphere. Now I'm going to draw a cloud here. So one option it has is that it comes into the Earth and it bounces back off into outer space. Another option it has is the radiation, the electromagnetic radiation can come from the sun and bounce off a cloud and go back into outer space. The one that we're really interested in is the one where the electromagnetic radiation comes onto the Earth. It is absorbed by the Earth and then comes back out as infrared radiation. Now, this infrared radiation hits a greenhouse gas. Remember, it physically made it vibrate or rotate, and that is ejected again. And then it comes out and hits another greenhouse gas. And then the infrared hits another greenhouse gas. And then it hits another greenhouse gas, and then it might eventually end up going back off into outer space. So what's happened is that these three are all coming in with the full electromagnetic spectrum. But when we hit the Earth, we slow it down. And when we slow it down, it bounces off the Earth slower with a longer wavelength, and that makes this infrared radiation. And these gases, these greenhouse gases, absorb this infrared radiation, and it gets bounced around into the troposphere, and therefore it's holding on to that heat. That's kind of how that works, right? So that keeps us warm. So if I look at the layer of the atmosphere I'm concerned about here, it's the troposphere. And if I look at the radiation I'm concerned about, the radiation I'm concerned about here is spelled this infrared radiation. So let's look at that real quick. I wanted to pull up the electromagnetic spectrum for you. So high energy is over here. These are the rays that are off in outer space. These are the ones, ultraviolet all the way through radio, that we have in our troposphere. Lower energies over here. So we've got ultraviolet, we've got visible, and here's this infrared spectrum. Notice that has a longer wavelength, it's a little bit slower, it's a little bit lower energy. Well, why is it lower energy? That's because when the sunbeam comes onto the Earth and it bounces off the Earth, it transfers some of that energy to the Earth itself, and when it comes off, it's a little bit slower, just a little bit slower. So we're talking about infrared radiation only. That's all we're interested in. Remember, you saw that in that simulation that visible and UV radiation did not excite the electrons at all, the molecules at all, just the infrared radiation. Now, what are the greenhouse gases? Let's look at what chemicals are involved. You guys looked at several yesterday: carbon dioxide, methane, and then you also looked at NO2, but I'm more concerned really about N2O. Remember, this comes from agriculture. Both of these come from fossil fuels. This one can come from decomposition, as can this one. So we're going to talk about some of the processes that create these. But this agricultural component is important because as we add more and more fertilizer to our crops and our monoculture, we're putting more and more of this into our atmosphere. So this is problematic. Now we can rate these. We can put them in order of increasing IR absorption ability. And it actually will look like this. And there's one other one, CFC. This is a chlorofluorocarbon. I'm going to talk about these more later, but CFCs are found in the in some kinds of materials that we use and are responsible also for depletion of the ozone. So we've got these, and then CFCs are actually the worst. So even though methane is a lot worse than, N2O is a lot worse than methane, which is worse than CO2. The big problem is we have lots and lots of that. So although these are greater infrared absorbers, we have the most of that one. So this is all happening in our troposphere. All right. Now, let's look at where some of these things are coming from. This will be a little bit of an introduction into what's coming up in our unit. So this will be a great summary. The causes of some of these things, we can look at where the carbon is in our environment. Let's look at our environmental effects first. We have glaciers retreating. We have ice caps melting. We have permafrost melting. Thermal expansion of the oceans. We're going to tackle that one tomorrow. Oceans. Stronger storms. Shifting ocean currents. Oh, this is just coming up in the news right now because of all the melting of the ice in Antarctica, causing the shifting of ocean currents. And remember, we learned that these ocean currents are absolutely essential for nutrition to move around the planet. Ocean acidification. Coral bleaching. Put on here sea level rise. We are going to look at all the environmental effects that are occurring. Why? Because as this happens, the average global temp is increasing. Right? Now, what are some of the causes? Let's real quickly. talk about what are some of the causes of the presence of these materials. We're going to work backwards. We've got carbon cycle has carbon in it. We get volcanic eruptions can be a cause. We'll talk about some of those. Right, they actually, and cows release methane gas, if you can believe that. Swamps and estuaries, wetlands, and of course, power plants, cars, rice farming. All of these things, I'm just going to put here, of course, as fossil fuels. When we look at a way to kind of summarize what's happening with climate change, we have this normal, really awesome process that keeps us warm. But if we keep adding greenhouse gas, greenhouse gas, greenhouse gas, we are going to keep that heat energy in the troposphere. More and more and more heat energy is going to be held in the troposphere, which is going to make the temperature go up. That causes all of these things to happen. The oceans are changing, glaciers are changing, currents are changing. All of these changes are occurring because primarily of these four main greenhouse gases coming from all of the places, as you can imagine. Primarily, if we're looking at CO2, our focus is fossil fuels, because that is where we are dumping enormous amounts of carbon dioxide into our atmosphere. So this is just a little bit of a summary of what to expect over the next few days, and we'll look into each one of these things in detail.